Okay, let's do some optimizing. Find two positive numbers whose product is 100 and whose sum is a minimum. So, two numbers, you could call them x and y, I suppose, and their product is 100, and we want their sum, which is just x plus y, to be as low as possible. So the obvious thing to do is differentiate this, but while it has two variables in it, that's not a terrific idea. So we would like some way to get rid of one of these variables and express this all in terms of either x or y, but not both. And we can do that because we have this other formula here, which says x times y is 100. If we say divide both sides of this by x, we'd get y equals 100 over x. So anywhere in this formula that we have a y, we could put 100 over x in its place. So that x stays put, and instead of y, we put 100. I'm going to put x to the minus 1 because I have a feeling a derivative is coming pretty quick. So here's our sum. It's these two numbers added together, and if we want to minimize that sum, we do its derivative and set it equal to 0. ds dx is, the derivative of x is 1, and the derivative here is going to be minus 100 x to the minus 2, and that must equal 0. Well, how do we solve that? 1 minus 100 over x squared equals 0. Remember that trick where we multiply everything by the denominator? If we do that here, we get 1x squared minus 100 equals 0. That's an improvement. Factor that, and you get x plus 10, x minus 10 equals 0 because it's a difference of squares. And from that we get two solutions. Either x is 10 or x is minus 10. Now, each of those comes with a corresponding y value, and the y is supposed to be 100 divided by x. So if x is 10, then the corresponding y is 100 divided by 10. So either they're both 10, or 100 divided by negative 10 is negative 10. So there's our two pairs. Except they told us they want the two numbers to be positive, please, so we end up junking this negative answer. And the only outcome that we keep that gives a minimum sum is both numbers are 10. The sum is 20. That's as low as we can get.